All right, so sketch a diagram for the following and state the definition you were using to solve the problem. Did you try and make a picture?
Yes, I did. I did make
Okay.
a diagram.
Okay, so they're vertical angles. Which is the middle letter?
It should be B.
B. So we'll go. I'll go A, B, C, D, B, E.
Yeah.
And if they're vertical angles, what does that mean?
Um, they're just like to be honest with you, I have no idea. I just know what they
Okay.
look like.
Okay. So here let's these are 1, 2, 3, 4. The one angle 1 is congruent to angle 3,
Okay,
and
yeah.
angle 2 is congruent to angle 4. So in geometry, there's kind of two things that you're going to see a lot of. The first is that they're congruent, or they're the same, and the second is that they add up to something.
180 degrees in this case.
Well, yeah, and well, if it says that. So ABC is 8x. This is 8x degrees in here.
Mm-hmm.
And DBE is x squared minus 3x.
Mm-hmm.
Okay. Now, just again, kind of give you some like aside information that's very helpful in geometry. You have to be careful because they sometimes ask you to solve for x, which they're doing here. Yay.
Yeah.
Sometimes they're asking you to use x to calculate something, like maybe it's a side, maybe it's an
Yeah,
angle,
yeah, we've had that. I've had that. I have that
area.
on another
Okay.
problem.
In my world, this is an intermediate answer, meaning that like it could be useful, it could also just be an intermediate answer. It could be not part of the equation. So because they're congruent, because they're vertical angles, because they're congruent, you can set up the equation x squared minus 3x equals 8x.
And then just solve for x, right?
Yes. To
We'll
do
solve for
that,
both x's. You just do x. Yeah. It should be minus 11x, and
yeah.
then you take out, and then you should have, and then you take out the x from both, and you have x minus 11, x equals 0, and x is 11.
So x is 11. Let's say it wanted you to actually find the measure of angle ABC. What would that be?
It's either 0 degrees or 88 degrees.
Okay, so it's either 0 degrees or it's 100. What did you say? 88 degrees.
88 degrees.
Right. Now it does say that one is extraneous. Do you know what that means?
Not real.
Yeah. So
Like that, like doesn't make sense.
okay. So here's what you did. You took a geometry problem and you turned it into an algebra problem. And just because it's a solution here does not mean, I don't know how to say it, does not mean that it's a solution here. What you did is what I call it is you changed the space of the problem.
Okay.
And spaces are a real thing. There's the real space and other types of spaces, and you have to always look out for that. Like just because the math gives me an answer doesn't mean that there actually is an answer to the thing that I'm trying to solve.
Mm-hmm.
All right. So what do you want to work on next, or do you want
Okay.
more? Do you want more explanation on this?
No, that's fine. We started like depicting circles. So we have a circle, and then it gives us a bunch of things about the circle, and we have to label them.
Okay. Can you give me an example of some words or send a picture or?
Yeah. Um. Yeah, I can actually send you an example of another problem. Um. Okay. Let me get my snipping tool out. Okay. this is just one example of the problem, but we can make more examples too, because
Okay.
I need help. Like, I need to work on this, because this is what we're doing a lot of right now.
Okay, I've got it here. All right, so this skill, again, if you want to just send some more things too, that would get us a little bit ahead here. But this skill that they're trying to emphasize here is can you construct an image from the given information? Maybe even calculate something. Now, sometimes in geometry they give you the picture. The more difficult problems are when they don't give you the picture, because the picture visually helps, with understanding. Have you tried to draw this?
Yes, I did draw this actually.
Okay. So the problem is you're going to draw it differently than I am. I'm going to give it a shot here. Center is A, right there.
Yes.
Great. Tangent BC forms a right angle with radius AB. Did you go up, down, left, right? What did you do for your radius?
I went left.
You went left like that.
Yeah.
Okay. That's B. And then BC, tangent. Tangent means it only touches at one point.
Yeah.
And I'll just put, did you put
That's
C up?
a point and made it
Where did you put C? Up or down?
I put it below.
Okay, C. And then chord BD creates a major arc which measures 300 degrees. So did you go this direction or this direction?
Yes, I did. I went for the first direction. Yep, like that.
Like this?
Yep.
Okay, so there's a lot going on here, and you actually, most students covering this class don't get into any of this. There's actually two arcs here, BD. There's the minor one. Sorry,
and this major arc. So our major arc should measure 300 degrees, and then our minor arc should be 4x squared minus x plus 55, and then you just set 4x squared minus x plus 55 to 60, and then you solve for x.
Yep. What'd you get for that?
I got x equals 5/4, and x is negative 1.
Okay. Are they both, did you try them both back in this?
No, I didn't.
Okay. Try that now and see if you get two numbers that actually work.
Okay. I'll try negative 1 first. So negative 1. So it should be 4 plus 1 plus 55. And it should be 60, so negative 1 is correct. 5/4. Okay, so. Okay. 5, right. 5 minus 5/4 plus. Okay, that one doesn't make sense. I think I did 5/4 wrong. Because we get 5 minus 5/4 plus 55 is 60.
Yeah, so the two answers I get x is negative 1 and x is 5/4. I can work that out if needed. They both work.
Yeah, I got 5/4 too, but when I plug 5/4 back into the equation, I get 5 minus 5/4 plus 55, and it makes 0 sense.
Well, remember, it's 4 times 5 over 4 squared minus 5
Oh, right, I
over
forgot
4.
to do the squared part of that.
Yeah. It was probably unfair of me. They both work, but it depends on that. So, like, you're covering the progression of the way you're covering this class is much different than other students, even at your own school, that I've seen in the past. Like, you're already talking about circles, which is great, arcs and stuff like that. What I see here, I mean, here's what I see is that your instructor is emphasizing solve some sort of equation, which we've seen a quadratic twice, in the context of geometry.
Mm-hmm. Well, yeah, that's what we've been that's what so geometry. He said they would have just found like without like with the circles part, they just wouldn't have solved for x
Mm-hmm.
because for our honors for us it's for our honors geometry it's just algebra, and honors geometry kind of have a baby.
Do you have like a list of, I think they call them the objectives, or the, I don't know, they call them the like areas, content areas, or?
No, I would usually get one of those, but I don't have one because of online learning.
Okay.
Because we don't know because we're not 100% sure yet of what we have to of what we're gonna cover still. If that makes sense.
Okay. Here's a, so, I mean, I could give you a circle. I could tell you that this is 30 degrees.
Yeah.
And what's the measure of this one over here?
Well, the other arc has to be 330 degrees.
Okay, so you know that. So the sum is 360.
360.
Okay. And then the only other skill that was kind of in here is like, can you you know, solve equations like this? Can you factor? And I
Okay.
think you can. I mean, we've done this so often. I mean, I'm very sure you can do it.
Mm-hmm.
So I'm struggling here with what to help you with, or what to cover. Do you have some more examples that you can send me of things that you'd like to work on?
Not really. We just started like labeling circles, so I just thought maybe you'd have something that I could do with that.
So have you been doing circles this week, last week?
Yeah.
Okay. This format doesn't work great for what I'm about to do, but label circle O with minor arc AB and major arc ACB.
Okay. Do I have something circular? I'm just trying to find something circular that I know. So I guess. A little small, but should be okay. Okay. So minor arc A B. This is A. This is B.
There's a lot of ways to do this. You could take a picture and upload it to the chat. It's hard for you to describe what you've done. I can give you one here that's correct. I mean, there's a lot that are correct. That's circle O. And then if that's A, minor arc B, as long as B is somewhere on one
That's
side of
pretty
this or
much
the
what I
other,
did.
you're in good shape. Like B could be here. And then as long as C is over here now, somewhere in this area, you're also
That
good.
works.
Okay. So
That's pretty much what I have.
all right, let's give me a circle with radius 12, and I want to draw something that has a chord of length 10.
Okay. Matthew, are you there?
Yeah.
Oh, okay. Circle with radius. Does that say radius 12?
Yeah, radius of 12 and a chord length of 10, or chord if you prefer. I found something that might be useful for us here.
Okay.
The point of this problem is that this is 12. What is the diameter? The diameter,
24.
24. So the diameter is 24. What is the main difference between a chord and a diameter?
Like the diameter is only halfway to the circle. The diameter is the whole.
So a
I don't know how
chord,
to explain it.
a chord does not go through the center.
Yeah.
So what's interesting about a chord is that it can never be as big as a diameter.
Okay.
So like this is a chord.
Yeah, that's what I drew.
And so is that. That one's there. So if you don't quite go through the center, the biggest the chord can be is it cannot be 24. In this case, it cannot be the diameter. The smallest, it can't be 0 either because it's got to touch the circle in 2 places. So it's somewhere in there. So if your instructor said, hey, I want you to draw a circle
Okay.
with chord 45, but it has to have a radius of 22.
Okay.
Go ahead and do that for me. Let me scroll. Oh, sorry.
Okay. Circle with chord of 15, radius of 22. Okay. By the end of this unit, I'm going to be really good at drawing circles.
Yeah, that's what they're trying to emphasize, I'm sure, in class.
Okay, radius 22. Chord of 20. Wait, that's not possible.
That's right. And I don't know if they're emphasizing that, but that's the kind of thing that you have to be on the lookout for when you're taking a class like this. You eventually do get to problems where you have to answer those questions, which we're not there yet. So let's do a little exercise here together. I'm going to snip in some things here. I think you'll just be able to tell me these verbally without much explanation, but this is as close to like what I think you might be asking me in general here. All right. So what is GH? What is this right here?
That's a chord.
That's a chord. Okay, so that's a chord. M. M is right there. What describes M?
Oh, M is probably it's a point of tangency.
Point of tangency. Okay. Is N a point of tangency?
No, because it's
No.
not touching the circle.
How about G and H?
No. It's
G
not.
could be right because it's on there, and same with H, but not the way it's drawn.
Yeah.
Okay, so what's the difference between a secant and a chord? Why is GH a secant down there, but GH up here, line segment GH and line GH? What's the difference between them up here? What can you see?
GH and
Here's
okay.
GH.
Why is it a secant? Is that what you're asking?
Yeah. Here's GH,
Mm-hmm.
GH line segment, and then here's GH line. What's the difference?
Are you asking why it's not a tangent?
I'm asking. Here's what I'm really asking. I'm not doing a very good job of. I'm asking what's the difference between this and this right here.
Okay, well, point GH is only it's only a select part of the line.
Okay, here is something that we do in our language which is totally wrong. We always say the word line when we actually mean line segment.
Okay.
So a line extends infinitely in both directions.
Yes.
Like your teacher at some point when we used to go to school, so would say, everyone get in a
When we
line.
used to go to school.
Yeah, everyone get in a line, right? Everyone get in a line.
Yeah.
Well, did it extend infinitely? Was there people out forever and ever and ever? No.
No.
But it's weird to say, hey, everyone get into a line segment.
Totally. That'd be totally. I'm gonna start saying that.
Draw a line on your paper. Well, I can't because I have to stop at some point, right? So we actually draw line segments all the time. We just don't say it, and I misuse it too. The difference between a secant and a chord, though, is that a chord starts and ends on the circle. This is what a chord is. It starts and ends on a circle.
Mm-hmm.
A secant, what it does is it cuts the circle, but
Yeah.
and it actually can go through the diameter, but it cuts the circle infinitely.
Yes.
But you actually can have a secant that goes through the center. Like this is a secant.
Okay.
It can go through the center.
All right.
All right. Let's go back to our picture here. Give me a radius in this picture that you see.
Okay. The radius. The radius is JK.
Give me another one.
JM.
So we have to be very careful here. We have to say line segment JM.
Line segment JM.
Line segment JK. Line segment JH. Your
Yeah.
instructor in this class is very, very particular. They want you to say it correctly. You don't get any, I think he meant this. It's a very frustrating thing. It'll probably be frustrating for you. We haven't even started talking about proofs.
Yeah, we don't have to do. I don't think we do proofs for another month or so.
So you're a very good math student, but you're going to have to adapt for this class. You're going to have to become a little bit more attentive to detail.
Okay.
And if you don't, you're going to lose points on tests and quizzes, not because you got it wrong, but because you didn't do it the way they wanted.
Okay.
All right, so let's try a couple more here. Tell whether the line or segment is best described as a chord, a secant, a tangent, a diameter, or a radius. So I'd like you, I'm going to ask you to spend the next like 2 minutes working on this, and let me know when you're all done.
Okay.
Okay, how are you doing on this?
I'm almost done. This looking to secant. It makes no sense. Okay.
Okay, tell me what you got whenever you're ready for 27.
Okay. I got a 27's a chord.
Agreed?
Um,
How about
28's
28?
a radius.
Okay, agreed.
29 is diameter.
Okay,
30 is a secant.
agreed.
31's a secant.
So it is actually a tangent.
I don't understand that.
Okay, so there's two pictures that you have to have in your sorry.
Oh, I see.
So I'm just going to draw them because I want you to have them. This is a tangent. It touches the circle once. A secant touches the circle twice.
Okay, thank you.
I think I once upon a time asked you some questions like how many times can a circle and a triangle intersect?
It's 3.
Well, you can actually have it up 1 to 6 times.
How is it going to touch 6 times?
Like this. 1, 2,
Oh,
3,
okay.
4, 5, 6. You can actually do them all because like the odd ones you do. I actually think this is a really cool exercise. The odd ones you get from tangents. So that's once, and if you want to get it 3 times, that's that. Sorry, that's.
Okay.
And then 5 times is the really hard one because it cuts it, but then it bounces. So you get 1, 2, 3, 4, 5.
Okay.
All right. Have you talked about concentric circles?
No.
Okay. How about the intersection of circles?
The intersection of circles. No. We
Okay.
literally just started circles.
Okay. Right. Let me paste this. And the instructions here say to do something, but I'm going to copy it in and wait for it. Okay. Identify a chord. So this is the going backwards question. This is the I don't tell you what it is. Now you have to figure out what each of these are. And I want to add in a tangent here, which is different than a point of tangency.
Okay.
So give yourself a minute here, and we'll see.
Okay. Wait, I don't think it.
If you're getting caught up on the first one, sometimes you have to add in lines, segments to do this, and that's the case for a chord. There is a chord, but
Yeah,
you can
I
also
know
add
that.
one in like this is a chord that's not drawn, but the one they're looking for is the one I'm drawing
Yeah.
here.
I just thought I screwed it up.
How are you doing on this?
Not radius.
Okay.
Do you want me to do a tangent too? Okay, yeah, I see that.
Yes.
Okay, so our chord is line segment EG. Our secant is line EG. Our diameter is line segment FG or FE. Our radius is line segment FC. Our point of tangency is D. And our tangent is line segment BA. Our tangent is BA.
BA, okay. I think I heard line segment, but
I meant
yeah, okay. So for example, if you wrote ED with a line symbol above it for chord, this would be wrong.
okay. What?
That's like your teachers are looking for that. If they ask you to write it, if you were to write, oh, it's line FE, that's also wrong. I don't want to do too many because I don't
You
want you
just
to.
have to have the line above it, right?
Yeah, well, this is okay. Well, this is also wrong. Line FC is also wrong because this is a line segment FC, or this is also wrong.
Okay.
So I think I've emphasized this. Brevity is better here, meaning less is more. Don't go and do more than you need to, unless you need to. Like don't add words, because if you add words wrong, it's worse than not having them. Okay, I found a couple of factoring problems I think would be good to look at just to kind of remind you how to solve them.
Mm-hmm.
So for example, I want you to solve 2x squared plus 10x equals 28. Solve by any method that you want, and then we'll review how to do some of these things.
Okay. Okay. Okay.
Right.
I'm almost done. Okay, I'm done.
Great. This particular problem emphasized factoring out the GCF, and that's always the first type of factoring. Did you get 2 and -7 as your solutions?
Nope, I got -5 and 2.
Okay. So I'm gonna I subtracted 28,
Yeah, so did I. And then
And
I
you
had
factor 2.
2x squared plus 10x minus 28.
Yep.
And then I had 2x plus 10 and x minus 2.
Okay, so that you'll find that if you FOIL that you said, give me 2x plus 10 and then x minus 2.
Yeah.
Okay, so let's FOIL this, because that's your check. 2x squared minus 4x plus 10x minus 20. Does that, sorry, that was a interesting thing. 2x squared plus 6x minus 20, is that what we started with?
No, we started
No.
with.
So just a reminder, sorry the screen sharing here thing. Reminder, you
Wait,
always
I
want to
know what I
factor out
did.
that 2.
I know what I did wrong. It should be 2x plus 14. And then I get negative 7.
Well, that may have worked for this problem. I'm not sure how you came up with that, but it's always good to get a 1 in front of the x squared.
Okay. Yeah, you always teach me this, and I always get it, and then I forget it right after because that's not how my teachers taught me it.
There is a time when you do something based on the number in front that's not a 1, but I'm not giving you any of those problems yet. So let's try one more here, and I really want you to factor out the GCF first.
So the way that you did that is like the exact opposite of how my teachers taught me it.
Okay. Well, I'll try to do one the way I think your instructor is showing you to hopefully emphasize the differences.
Mm-hmm.
But for now, could you factor out the GCF for me?
Yeah, I just didn't realize there was a GCF, to be honest.
It's a really common thing, especially in standardized testing, to make it look harder than it actually is.
Okay, so I'm where you're at right now.
Okay.
So you factored it at 2, right?
Yes.
Why don't we just divide the 2 from both sides?
Okay, you can do that. You can do that. But what you're doing graphically, and I think you'll appreciate this. Actually, let me. There's an answer here, and it's not just me trying to talk extra. There's actually a real thing here. So let me share my screen so that you can see what it is that I'm trying to show you.
Okay.
Why is that one? Huh. Oh, there it is. Okay. So here's what you just asked me. We're gonna type in the original 2x squared plus 16x plus 24. Do you see that graphed here?
Yeah.
Okay. Where does it hit the x-axis?
-6 and -2.
Great. Now I'm gonna graph this. Where does it hit the x-axis? That was a question.
It's the exact same places.
It hits it at the same place. Okay. Where does 1/2 x squared plus 4x plus 6 at the x-axis?
The exact same place.
Okay. Now I can even flip this over, and it's the same thing. Now, are you solving the same question each time?
No.
No, but there is something about that allows them to have the same solution. So yes, you can divide, but you need to know that you're not actually solving the same thing. Like you have to understand that even though you're dividing, which you can absolutely do, you're not solving the same thing. So that's why I don't do it. The best example of that is if I tell you to solve something like 3x squared plus x equals x. Let me go 6x here. If you divide everything by x, what happens?
I think your screen might be frozen if you're not on that
Okay, you're right.
graphing page.
You're right. I apologize. That's one of the. So I'm going to share the correct screen, and I'm going to undo a few things here. One of the limitations of the site needed some sort of a screen mirroring thing. So if I asked you to solve this, and you just divide everything by x, because it seems reasonable, you get 3x plus 6 equals 1. You have lost a solution. When I say lost, I mean you basically ignored it.
Yeah, it's because x could be 0.
X could be 0. So there are problems where if you divide, and you were dividing a number, which is why it was okay to do, you never want to divide by a variable because you lose it. So that's why I suggest factoring and leaving it.
Okay.
So you get two things here, x plus 6 equals 0, and then x plus 2 equals 0. So x is, or x, there's two values for x.
Okay.
All right, so I found some questions that we can look at now, which will better, we were talking about this idea that, okay, I can't just, what if you can't factor out a GCF?
Then you just.
So here there's no GCF to factor out. So there's this, when A is not 1, and this is A is leading, when it's not equal to 1, which is the case here, you end up multiplying these together, the first and last. 3 times 20 is 60. You're looking for two things that multiply to 60 to give you negative 16.
Okay.
So like 1 and 60, nope. 2 and 30, nope. 3 and 20, 4 and 15, 5 and 12, 6 and 10. Hooray, I found them.
Yeah.
Do these add up to negative? Do these as is add up to negative 16?
No.
No, but if they're both negative, they do.
Yes.
So you take this right here, and it becomes minus 6x minus 10x plus 20, because these add up to that. And then you do what's called factor by grouping.
Yeah. I already know I'm gonna forget this. We've done this at least 4 times now.
Do you recall doing this?
Yeah, and then you have to multiply by some number to make those two equations equal.
Yes. And then you have to, it's really double factoring.
3x. Yeah, x plus 10, 2, and then 3x minus 10, yeah.
Okay, so this is not, I don't think this is what you're doing. There is kind of a guess and check way to do factoring the way I showed you before, or the way you were showing me.
Yeah, that's how my teachers taught me it.
I used to do it that way, and I've switched to doing this way because it's easier to explain, and it always works if you follow the recipe. It's like if you make pancakes in the morning and you follow the recipe, usually they come out okay. If you do whatever you want, sometimes they don't come out very good. So you got some options. Let's do one more here. I want you to solve 3x squared plus 10x minus 8 equals 0. You can use guess and check on this, but I'd encourage you to multiply the first and the last.
Wait, so I should make it negative 24 though, right?
Yes, very important.
Okay, I found it.
Okay, what did you come up with?
It should be negative 2 and 12. So 3x squared minus 2x plus 12 x minus 8.
Now, do you know, are you comfortable answering this question? All I did was switch the middle two terms. Does this also work?
Yeah.
Okay, yes.
Yes.
Which one appears to be better for factor by grouping now?
The second one.
Yes, and they both work. They both get you the same place. I'll show them both here. Like this one, you can only factor a 3 out of, so you get 3x minus 2. And on this one, you get 3x, x plus 4. Yes, and then minus 2, x plus 4. So you end up getting to the same place.
Just quicker.
It's just that you can potentially be unsure of your answer, which we obviously wouldn't want.
What?
All right. We are basically out of time. I'd like to really quickly remind you of my virtual homework help. It's an extra opportunity to get your questions answered. I'm just going to show you again how to sign up for it. It's totally free. It's under the Meet with Matthew tab, and it's the third option down here. It's Monday at 7 is the next one. So just got to sign up. I mean, I'd be happy to answer any of your homework questions. So, or whatever concept, whatever you need, because you know, I want to support you and your learning. Make sure you let your brother know that this is available if you happen to see him today.
Yeah, we need to talk about my like how to get my brother signed up.
Same thing here. You know, it might be a good option for you guys. So that is all I've got time for today. I'm going to send these notes out to you as a PDF right away. The video takes a little longer because there's a Zoom delay and then a processing delay.